you.
It's a great pleasure for me to introduce the next speaker, who I think is known to some of you in the audience. Matt Grob is the CTO of Qualcomm. He's actually a robotics enthusiast, I'm told, and he also says he almost went to MIT, which I think is fantastic. He apparently went to the other school on the West Coast. I don't know what the name is, but it's further north. They have an engineering school. They have a good program. And I think he's done pretty well for himself. Without further ado, Matt Grob.
All right. Thank you. Thanks a lot. Geez, I'm really delighted to be here this morning, and I love to talk about robotics in particular. And it is true, I've loved robotics pretty much my whole life, and I wanted to go to MIT and study robotics. I got on the wait list and ended up going to Stanford. It turned out okay, but it is true that while I was there, I built this robot, and when I came to interview at Qualcomm, I showed him my little circuit board that I built, and I think that helped actually to get a job. So let's talk about what's going on with robotics and our involvement in it. So robotics are robots and the different designs are starting to be used, all across our lives. For me, R2-D2 was like a huge life-changing moment. That was in 1977, and it's come a long way. So here's this little kind of animation to depict some of the things that are being done. So these are kids doing drone races in the park. There's an automatic dog walker. This is not in the future, of course you know that. It's in the past or present for sure. Here's drones helping law enforcement catch the bad guys. We also maybe catch the good guys, which is not good, but you can use it to deliver packages. It's also used sometimes, in that case, for tools, packages into your window. I was just mailing last night. If you've not seen Dodo Pizza in Russia, where they deliver pizza, been doing that for a couple years. Farming, agriculture, there's huge applications there for these kinds of things. Public safety. And of course, I'm talking more here about mobile robots, okay? Mobile robots, flying, rolling, and that's in addition to, robots for automation, production, factory, which are also having a huge impact on the world. Here's again a farming case. Okay, so, is the world noticing this stuff? Of course, robotics enthusiasts and nerds and experimenters and researchers have been following this for years, but is the world noticing how big is this becoming? And fortunate enough to be able to go the past couple of years to the World Economic Forum, and this year the theme of the forum was this notion of the fourth industrial age. And there's a book called The Fourth Industrial Age by Klaus Schwab, who is the founder of the World Economic Forum. And just kind of to rattle off quickly, the first industrial age was like steam power and mechanization, and then we had factories and mass production, and then we had the information age, where you can get information. But now we have a new age, which he calls the fourth industrial age, which is the rise of cyber-physical systems. And this is where you have machines that can actually take advantage of the information and the connectivity to do computation right there on the spot in real time and potentially mobile, and really change the world. And as you can see from the quote here, and actually the theme, what this does to society is a huge topic. I mean, you're starting to read about this every day. You didn't read in 1977 when R2-D2 came out that it's going to take the jobs away, it's going to change this economy. You didn't read quite as much about that. There were, of course, a few voices, but now that's like on the table. It's right in front of us. So we have to confront that. And as an example, again, at this event, I was fortunate enough to meet mayors from around the world. There was like the Council of Mayors. And they talk about the impact of urbanization, in India, 140,000 people a day moving into cities, and the traffic and the impact on infrastructure. So, and transportation. Well, if you went to the CES show this year and you walked into the drone area, you saw a drone that can carry a person. And you start to think, okay, well, cool. I can now go 3D, and I can make a flying car. Flying car is not a new idea, been around for decades. But where are the flying cars going to come from? Are they going to evolve from the airplanes? Are the airplanes going to turn into flying cars? Are cars going to turn into flying cars? Maybe, probably not. Are these kinds of things going to turn into flying cars? That's much more likely because of the nature of their capabilities and how close a flying car is to what's already being done on a large scale. So it's possible now, and I'll go into a little bit of detail, to put so much capability in a device like this that it really is going to bring in this fourth industrial age, and we have to think about what that means. Okay, so at Qualcomm we work on mobile technology, and that includes the chips that are in your cell phones at an enormous scale, and there's a large developer ecosystem, huge, and the major players introduce new products every year, sometimes even faster. So there's a rapid development of innovation, which has resulted in costs dropping out of it, and wider scale and so forth. So that's a key element for mobile robotics development to take place. And we also invest a lot in R&D. $40 billion since the beginning of the company, something like $30 billion over the past decade. That's not all long-term R&D, that also includes product development, but it gives you an example of what's taken place to get us to where we are. Now, one of the things I like to point out is it's often the case you look at a flagship smartphone and you're like, wow, that's amazing what it can do. And it is, no doubt. In my mind, what's equally amazing, although I'm at risk of saying this, is not the top one, but the middle one. The mid-range one, the so-called value tier, is also amazing because of what it can do for the price you pay for it. And it's that kind of module, inside of a phone, like this phone. The actual phone part of the phone is only a little piece of it. You open this up, a lot of it's the battery, the display. The actual phone, which is a supercomputer with connectivity, cameras, media features, position location, security features, capable of doing financial transactions, it's got sensors. That's now, you can do the cost of that to a vendor who's making it in volume and scale at the mid-range is something like, a sushi roll or something like that. And that's what's going to really change the picture for these kinds of machines. All right, so it's come full circle. When I started here, I wanted to work on robotics. Well, actually, this will maybe end up to be our mission. Sensor processing, navigation, computer vision, real-time control, machine learning. This is what one needs for these kinds of machines. And when we started looking at, for example, consumer drones a couple of years ago, when we started looking at that, and by the way, why did we look at that? Because we kind of think higher volumes. That's just kind of the way the company is oriented. And of all the different robotics types, that was the fastest growing and highest volume sector. It's not meant to be the only one. We're looking at lots of other things too. But we found that our platform for smartphones and what was needed for these devices was almost the same. And we were able to leverage a lot of these billions of dollars of R&D that's been spent to get the cost out of these capabilities for these kinds of machines. And I can see my laser doesn't work here, but maybe this other one will work. What are the drone vendors, what are the robotics vendors? Much better. They ask for these things. You might say, why do they ask for that? Because they want it to not crash. They want it to not run into the building next to it. That's very challenging. That means more than GPS. It means GPS, but it also has to work indoors. And when it's not, when GPS is impaired. So you have to do computer vision fused with GPS, fused with sensors. And you need to do some machine learning. So when you say come back to home and there's an object in the way, it can find its path around. And we're gonna shrink all that into a tiny module and make it low cost. And that is really gonna make a huge, huge difference. Here's an example. This is a teardown of a consumer drone today. You open it up and it's a bag of chips because they've gone to a vendor for the camera, they've gone to a vendor for the flight controller. They've gone to a vendor for the app processor. There's a different board for the gimbal. There's one for the radio. There's one for the GPS. Right off the bat, we were able to do this. And this is really just the beginning. It's going to shrink dramatically even from there. Now, that also not only makes it lower cost, it also makes it smaller and lighter, which makes it safer. Recently, the FAA said you have to register your drone unless it's under 250 grams. So just to calibrate, like a can of soda is like 300 milliliters, so it's a little bit less than a can of soda. Now there's a race to get to products that are just under that threshold and still be fully capable with 4K cameras and machine vision and stabilized video and so forth. And we can now do that at low cost. So here's a couple examples of smartphone or mobile technologies being used for this sort of thing. So this is at the lab, at Vijay Kumar's lab. His folks put this, he calls it a Flown. It's a smartphone flying this drone, and the actual, including the flight control, is done in the phone. It's not just for the display, and it's using computer vision to look at things on the wall and to navigate itself. Here's another example of different kinds of machines we made here at Qualcomm. Again, they're flying around, and they're using, they have cameras both forward-facing and down-facing. They can do depth from stereo in real time at low cost. This is a technique called visual inertial odometry. So you take the cameras and the sensors, you use them both, so when the sensors drift, you can correct with the camera. And a person is walking out of the building, down the stairs, out into the front yard of the building, getting on, I think, a bicycle here, riding almost a kilometer around the block, and then walking back into the same building, and you can see the bird's eye view there. And when they get back to where they started, it's only like a meter off, even though they went like almost a kilometer. And these little annotations are objects that it found. And this is at super low cost. You can put this on pretty much anything. And then here's an example of 3D reconstruction, which is, again, a thing. These take reasonable processing power at the device. So another point I want to make on this is, in addition to the platforms, the developer boards, and so forth, we're doing all of these things. We're in many ways expanding our participation in open source. We have ventures program. We invest in startups. We do a robotics startup incubator. There's a lot of innovations. We're working to enable commercial use cases. So right now, just across the street here is, we think, maybe the first outdoor flight center that's approved by the FAA. Now you're thinking, well, that's not the first thing. That's happened before. But we're 2 miles from a military airport. So it's Class Bravo airspace. That is a little bit unique that we're allowed to fly in that kind of a situation. And how did that work out? Well, it turns out these things are an issue for the regulator. They're everywhere, and what are they going to do? And we are going to work within that construct. So there's a radio there. We talk to the tower. We conform to the protocol. We're working with the FAA. And we want to get to the point where, by the way, the team is now coming up to speed in the presence of air traffic control. Everyone on the team is doing this all the time. And so similarly, air traffic control is getting used to us. And we want to pave the way for these devices to be connected all the time with a secure, high-speed, ubiquitous link that is not necessarily line of sight. And that's what's going to unlock the commercial use cases, the package delivery. It's not going to start on day one going into a dense area with a big, heavy, a new hammer for your workbench. But it might start with prescription drugs or highly critical things or surveillance of agricultural, and done legally, safely, within the control of the regulator so they can administer the airspace. And it'll have all these along with the connectivity, and we're very, very excited about that. Okay, I think I'm just about to the end. Okay, so just as a final comment, really, again, glad to be here this morning and to talk to you. Everything I've talked about today is not a phone. If you've watched the robotics blogs over the past week or two, you saw the Cosmo, which was in the news this week, made by Anki. I was trading mails with them last night. That is a super exciting. It's a little personal robot. I think those are going to start to get more popular because they're getting more capable. You can see what Boston Dynamics has done with this, I don't know what to call it. It's kind of like a dog with an arm on it. It comes into your kitchen and it puts your dishes carefully into the dishwasher, which is like a holy grail thing. And if you haven't seen, how many have seen this video? Ah, wow, cool. I love this audience. I mean, it's amazing. When you watch that, it's like science fiction becoming science fact. The only difference between science fiction and science fact is time. So we're totally excited about this. I think it's something, an area that Qualcomm can leverage its investment. We need to be connected to all of you folks here with startups and research, and that's what we need to do next. Thank you.